It's convenient to have the kitchen and the dining room in the same house. However, you don't want to store your pots and pans on your sofa. In the same way, having a monolith code simplifies operations, but you don't need to have a spaghetti monolith nor take the framework as your application. HTTP is just an interface to access information that we should be able to access by other means. Let's reflect that in the structure of our code. We create a top interfaces HTML directory where we put the previously created lib directory. In addition, we nest what is inside it in a planet-wide interfaces HTML directory within. This may seem confusing, but the distinction is clear. The top interfaces HTML directory is just the place where we put our subsystem, while what's under lib will follow the traditional Ruby convention between directory and module hierarchy. The time has come to clean up the bloated Rackup file. Following traditional conventions, we extract the entry point class to a showAction file. Besides requiring only what we need, we have to update the relative path to our container, while in config.ru we must require the newly created file. The domain logic in our application consists of the calculation of an Earth weight on another planet. Currently, this is coupled with the handling of the request. Just like we've just done, let's create a core top directory that will accommodate our domain logic. We're going to call operation to this kind of piece of behavior. Let's use dry monads maybe type to design a clear interface for an operation that can return a result or nothing when the planet is not known. We're going to use this operation from the action class, so we need to register it in the container. Keeping track of the place for each file is starting to get pretty crazy, but we'll fix it in a minute. In the action class, we're going to merge the fetch factor and calculate steps. We get the operation from the container and try to calculate the result. We've required dry monad so that we can pair or match on the return value. When none is returned, we display the error message, while on success we bind the return planet weight and add it to the connection struct so that it's consumed later on the render step. Let's fix now the way we are assembling the different subsystems. We're going to use dry system to manage our dependencies in a free of magic way. Just updating Ruby's load path and with no automatic constant resolution. Following dry system convention, we create a system directory alongside lib. In a boot.rb file, we set a bundler and require the container from a new location inside system boot. Once done, we can freeze it. The container is going to be provided by dry system itself. We don't need to manually require anything. Instead, we configure where the root of the subsystem is and its default namespace. We tell dry system to auto-register the lib directory, so this will allow us to use regular require statement for our own code. We do the same in the core subsystem, using the core module instead of interfaces HTML. We need to reflect the fact that core is a dependency for the HTML interface. So we require the former from the HTML container and make everything available within the core namespace. We can now update our code to fetch other files from the load path, instead of being brutal relying on relative paths. In order for Dry System to do the auto-registration, we also need to make sure that we are following the file module hierarchy convention, as we had been too lax until now. Lastly, the only responsibility of the rackup file will be booting the HTML interface and running the router. We update its name and we use a container to resolve the action class. We can also use Dry System to easily inject the dependencies. For that, we create an import module that we spin off from the container. We can use it in the action class to inject the calculate weight on planet operation. In order to be consistent, we can remove the container extension and inject the view also through the import module. We'll go one step further in the organization and separate dependencies for each subsystem in different groups in the YAML file. We tell Bundler to set up only what is required for each subsystem. That's been everything for today. We've restructured a lot of our code. Some of the changes are opinionated. The nice thing is that these tools are very sharp and you can completely adapt them to your needs. Thanks for watching. Remember, you can play with the code on the GitHub repo. See you next time.